All right, hi everyone. Welcome to this deep dive on the official Couchbase Prometheus Exporter. Presented by me, Dan Moore, a software engineer on the cloud engineering team based in Manchester. So for today's presentation, first of all, we'll be going through a bit of background about why Prometheus in Kubernetes and the standardization of the technology within Kubernetes. Then we'll be moving on to the actual exporter itself, some of the design considerations we took, the architectural overview of the Explorer, different run configurations, and then finally a deep dive into the code. So for the standardization of Prometheus in Kubernetes, first of all, Prometheus, what is Prometheus itself? Prometheus is a monitoring and alerting toolkit, exposes metrics in a time series format, identified by metric name and a bunch of key value pairs. As you can see in the example Couchbase Exporter Prometheus metrics we have at the bottom. Originally built by SoundCloud in 2012 for their monitoring needs, Prometheus exports a simple text-based metrics format and uses this text-based metrics format and consumes that within Prometheus server. Prometheus server also has a rich, concise query language called PromQL. In conjunction with Prometheus, Grafana is used quite often with Prometheus, and even though Prometheus has its own graphing solution and query console, Grafana is an extensible, more customizable dashboard solution and visualization tool that accepts metrics from a variety of different data sources, not just Prometheus. Initially, it targeted time series databases like Prometheus, but has expanded further later on for stuff like SQL, traditional SQL. So how has Prometheus become such a de facto standard for Kubernetes and for cloud native solutions? Kubernetes itself is instrumented for Prometheus, and there are abundant exporters for the ecosystem. Prometheus also joined the Cloud Native Compute Foundation as of 2016, which is a Linux Foundation project founded in 2015 to help advance container technology. Kubernetes itself was inspired by Google's Borg, and Prometheus was inspired by Google's Borgmon, respectively. Borgmon being the internal monitoring service for Borg at Google, and Borg itself was a Kubernetes predecessor, outlining many basic fundamental parts of Kubernetes, such as pods. So you can see how well suited Prometheus is when it comes to working with Kubernetes. So onto the exporter itself and design considerations we had to take. When looking at the Couchbase REST API and the Couchbase statistics, we wanted to export each node, or each Couchbase node itself provides cluster-wide statistics for that Couchbase cluster, but also each node also provides per node statistics that must be taken from each individual node. So here we have an example of cluster-wide statistics in the top picture, and in the bottom picture you can see that we have node labels for each of these stats. Pardon me. As you can see, they vary from each different node, so number of current items on each one. Oh, apologies. And then in total, you can see at the bottom here that current items total has more or less doubled because of the replicas. So the exporter itself was a requirement for Autonomous Operator. So we first focused on the Autonomous Operator design. This is our initial design with each Kubernetes pod containing a Couchbase container. The metric sidecar container basically will run the exporter, and this will query NS server and the REST API statistics within Couchbase. Once this has converted Couchbase metrics into Prometheus key value pairs that can be consumed by Prometheus server does just that, and then from Prometheus server we can then export those statistics into Grafana, and then we can build custom dashboards. a larger overview of how a typical Kubernetes or a typical operator setup might be with 3 Kubernetes pods, each one having a Couchbase Exporter sidecar. Proposal is to run one single Couchbase Exporter per cluster, which is a request we've had quite a lot. As obviously with a Couchbase cluster running an autonomous operator, or just a Couchbase cluster in general with lots of nodes, this can get quite expensive in terms of having to have an exporter sidecar on each one. So in this scenario, in this architecture, we pull per node stats individually from each node, and then also select one random node to pull cluster-wide stats from. If that node suddenly goes down, then we can simply just choose another. So this is something we're looking to do in the future. So architectural overview. We might be covering some of the parts we've already just mentioned in this part, such as under the hood. We've already seen this diagram. Here is an example of the targets in Prometheus server. So if we go to the localhost 9090 normally for Prometheus default, and then /targets, you'll see here in our service discovery, we've discovered the Couchbase endpoints, or the Couchbase Exporter endpoints. And this is where Prometheus server scrapes our Couchbase metrics from. As for a deeper look into how the Explorer works, the standard collectors here, bucket info, bucket stats, node, and task, follow the Prometheus collector architecture, which basically collects on demand every time Prometheus server queries our exporter endpoints. What is different here is that per node bucket stats pulls the Couchbase server API, and that is for each node. So that will poll on a regular time interval, the default being 5 seconds. So that is a slightly different architecture to our standard exporter collector architecture because of the way that we collect per node statistics from each node. So moving on to run configurations. Obviously, I've already explained that the Couchbase Prometheus Exporter was basically a requirement for Operator 2.0. So through the inclusion of a sidecar container in each Kubernetes pod, we can export Couchbase statistics in a format suitable for Prometheus server consumption, as I've already explained. So this is something we've already quite covered quickly. Feature operation. How does this work within Couchbase Autonomous Operator, you may ask? So we basically enable this feature through the Couchbase cluster resource. The exporter image is then responsible for conversion and serving to Prometheus metrics, which is filled in as a default, but then can also be overridden within the YAML for the Couchbase cluster resource. So our configuration starts through the CLI, which basically is your standard kubectl create Couchbase cluster YAML. Then you move on to third-party UIs when you want to configure your Prometheus setup and your Grafana setup. So as I mentioned, our Couchbase cluster spec, you go into monitoring Prometheus and then enabled true. That is the minimum setup you need, actually. Image and authorization secret. Image will be filled in by default, provided you have the admission controller running. Authorization secret is an optional authorization secret if you want to include a bearer token to protect some sensitive metrics data that you may have. This is a little bit of an old slide, but as of right now, the latest exporter version is 1.0.2. 1.0.0 has compatibility issues with Operator 2.0.0, which applies to Docker Hub only, but we would just recommend to use 1.0.2 basically. Don't deal with older versions. So how does this feature setup look? Basically, once you've enabled the Couchbase cluster and have it up and running and it passes all the admission control checks, each pod should have 2 ready containers. Obviously, if you're editing an existing cluster, a role upgrade will be performed. As you can see here, CB example 0004 has come up and 0000 has been removed. and that continues until you have 3, 4, and 5 with 2 ready containers per pod. So once this is up and running, you can check that the Prometheus statistics are being reported correctly by making sure, first of all, by making sure port 9091 on any enabled pods is open, as 9091 is the default port for Prometheus metrics. You could do a simple port forward and then check your local host 90901/metrics and should see output similar to the key value pairs we are so accustomed to by now. There's some basic troubleshooting you could do. Basically, simple kubectl get pod, name of the pod, and -o YAML will give you statistics such as the state of the metrics container, so ready, true, if it's started, whether it's running, the port number, readiness probe, etc. Also, what you can do is kubectl logs and then the name of the pod, which should give you basically the logs of Couchbase Exporter out of the. You can also run the exporter as a standalone binary. This isn't supported currently by the company, but basically you supply the arguments that you'll see in the GitHub repo, and then run the binary standalone. There are planned future improvements for this in terms of distribution within non-Kubernetes systems. So, about to head into a deep dive of the code itself. So a simple workflow would be the setup stage where we take the arguments and we pass those. Then we move on to setting up a client that will query the Couchbase server REST endpoints. Once this is done, we'll create collectors, as we mentioned before, and register these collectors with Prometheus. And once that is done, the collectors will take the metrics from the endpoints, statistics from the endpoints, and then serve those metrics for Prometheus server consumption. So yes, during our setup phase, yes, as I just mentioned, Couchbase server location, address, and port and credentials are very important for polling Couchbase, for reaching Couchbase. Our metric server networking options, and then how often to poll nodes or per node statistics, as I mentioned earlier with the per node collector. Any security arguments, including our bearer token, secret, and any sort of PKI, so public key infrastructure. And then login options, so the verbosity of the login. Just a quick overview of the REST endpoints we'll be hitting in Couchbase server. Our red row column here is something we don't currently use in the exporter, but most of the others we do. And here is some of the statistics for the optional services. So I'm going to take a look at the code here. Obviously, as I mentioned earlier with the setup, we have a bunch of Couchbase server-specific credentials and variables, so such as where the server is located, the port, the credentials as well. These are overridden by environment variables that we set in the Couchbase with the Couchbase operator. So because the Couchbase operator already knows, obviously, the Couchbase server credentials, we can just take that from the mounted secret, which is great. Makes that definitely very secure. Obviously, when you're doing it standalone, you have to probably pass that in via plain text. Next variables will have our server address and server port. So where we want to host our metric server in terms of on the pod, or in terms of when you're running standalone, just where you want to host it, basically. And our per node refresh, which is default 5, as I mentioned before, how frequently we want to collect our per node bucket stats collector. And then our bearer token. So did mention actually earlier, I didn't mention earlier, but there's an example of that secret that would contain that bearer token if you were doing this in the operator. And then our PKI files, and then some some arguments for basically our log level, and then whether we want the logs to be JSON formatted. I'd like to thank Antoine Huret for contributing mostly to that extra login functionality. Made it a lot more sophisticated than it was before. Something I'm working on currently with the backoff limit, not currently out for consumption, general availability. Basically, how many times we should restart the program if we encounter an error or a panic. It's important just so we don't keep trying forever and we don't keep adding to the logs. So that's coming soon, I believe. So yeah, our main setup, we just basically pass our arguments, set our log level, set our log formatting if it's required. Then we start our metrics collection by validating our arguments still, seeing if they're actual integers and are valid input. Take our credentials from flags in our standalone mode. We override the flags if environment variables exist. So this is for any sort of operator setup. And then for operator only, we'll override both plaintext CLI flags and other environmental variables. So I guess, sorry, this is, you can set environment variables inside your Linux distribution or VM. But yes, for the operator, we also grab this. So credentials, so yeah, that's good. Then we go on to create our client. Setup in terms of CA setup, if we're using TLS, we'll just go ahead and do all that. Good error checking to see if we need both a client cert and a client key. If we don't have both of those, obviously TLS setup will fail. And then we dial the CB Couchbase server at this address and then return the client, and that gets created. Here gets passed back. Then we register or create all our new collectors. So these standard ones: node, bucket info, bucket stats, and task. Then optional ones: query, index, FTS, CBS, CBAS, event. And obviously we'll create these every time, but obviously if you don't have FTS or index enabled in your cluster, these just won't return anything. And then we register these with Prometheus itself. Get the refresh time to see how often we want to poll for per node bucket stats. This per node bucket stats collection then just happens here. So this per node bucket stats collection happens here. We retry a couple of times. Obviously, if we can't retry the 8 times, 20 seconds each time, we will error out with false return. And then collect per node bucket metrics. We'll just keep trying, set all these gauge vectors, a lot of statistics, and we run this every how many seconds? So 5 is normally the default. And after that, we serve our metrics in a for loop. And in here, we serve our metrics. And this basically is what Prometheus server will scrape, which is this metrics endpoint, as you can see here. So as I mentioned earlier, localhost 9091/metrics. And that's really all there is to it for the main setup page. If we look at the collectors package here, so our collectors package, first of all, our meta collector is part of each collector, which just tells us up, whether the collector's up, and our scrape duration will tell Prometheus how long it took to scrape that particular target. If we check out bucket info with the collector, there's not that many in here, but we can see we define our collector structure. Then we describe, we describe each metric, and in that metric, the describe metric basically will take help and our any labels and const labels, and basically populate the information in our collector, and then collect itself will actually do a client call to Couchbase server. So here are client buckets. We were expecting a bucket info object back, or an array of bucket info objects, because there might be, well, more than likely there'll be more than one Couchbase bucket. And then we make a call to pools/default/buckets, return this object, and basically take buckets. And then for each bucket in buckets, we'll grab the data and format those into a Prometheus key value pair. And that's basically similar for all these collectors. So we have our eventing collector, the subsystem being eventing. So of course, I just failed to mention earlier, CB is our prepend for each metric. We're working on a system to get that, to basically you'll be able to customize what you want to call these metrics, basically, in a way. So prepend like CB or Couchbase, or maybe no CB at all, and then you want CB underscore eventing. Maybe you don't want CB underscore eventing, you want Couchbase underscore eventing, or maybe you just want eventing. We're looking at doing that so there's more consistent statistics all around, and also just basically for easier human readable statistics and easier renames. But of course, this is also all open source, so you can go in, fork the repo, or just download the repo and just change things as you might change things to the format you wish. So yeah, this isn't fully the help stuff. As you can see, we're missing some of the help descriptions for statistics, so it's not fully, nowhere really fully complete in terms of that. So yeah, those are our collectors, and in our objects folder, these are basically the structures we have for the API REST data, the API REST structures we get back. So we put those into JSON. This is just, we kind of need to do this because it's just the way that Golang handles JSON and interfaces. We need to be able to refer to these directly in our collectors, as you can see here with ev.op.samples.event nickel operation exception count. We need these to be explicit. And then in our util folder, we have a simple retry util, which is basically, helps with retry and network calls. And then in networking.go is where we basically create our client, or our Couchbase client. We also, all the help functions for querying the Couchbase REST API. So, and then also, so we already mentioned earlier, buckets, bucket stats, bucket per node stats, nodes, cluster name, nodes, which is basically nodes returns the results of pools/nodes, and then bucket nodes, tasks, servers, query, index, etc., query node, index node. You get the picture. And then server now HTTP or HTTPS for the Prometheus server to scrape our metrics. Moving further on, we have a bunch of example rules in alert rules that is slightly outdated right now, but obviously with monitoring, you also want to get alert in. So these are kind of example rules in there. Then for our Prometheus YAML, here we specify alert rules as example rule files. And then our Couchbase job name, which is important. So Prometheus can discover our Couchbase metrics, metrics path being metrics, and then the target being localhost 9091. Furthermore to this, we have two probably not as up-to-date Grafana dashboards in Grafana Kubernetes and a Grafana local, which is just one. If you say you're running a local Couchbase server instance on your laptop, then this would be helpful for that. And a Grafana Kubernetes JSON is what I normally use for running in the operator, so the Couchbase operator, and then in conjunction with the Prometheus operator. That's what I normally use. which is this JSON here. So we're just going to quickly, show you the rolling upgrade in progress, and then how to set up Prometheus and Grafana the way I do it normally. So kubectl get pods. See, currently we have a Couchbase cluster up and running. If I get kubectl get Couchbase cluster, see what we have in it currently. Currently I'm running a backup, sort of doing some development with backup. But obviously no monitoring here. So we can just change that by editing and go in monitoring Prometheus enabled true, and that should fill in the defaults as I mentioned earlier. Just look at the monitoring, see if it's filled it in, and it has filled it in with Couchbase Exporter 1.0.2 default. So now we should start seeing the rolling upgrade happen. So as you can see, this one will have 2 containers, and this will run for a while. So we'll just let that do its thing. Okay, as you can see, the rolling upgrade has finished. It's taken a little bit of time, but nevertheless, it gets there. So what we're going to do now is I'm going to check out this repo here, which is Prometheus. Basically, what this does is it's basically one of the easiest ways you can set up Prometheus Operator, also with Alert Manager, Prometheus, and Grafana, and Kubestate metrics as well, all in one pretty tidy little neat package. So this is what I normally do when I want to get Prometheus up and running and Grafana up and running very quickly. So I've already got Minikube up, and we're just going to quick start this now by creating these service monitors and manifests. So one quick thing is that, as you see, I've created this repo called Prometheus Mine. So there is a difference between what you just saw on that GitHub repo and what I'm running here. I've got a bunch of custom things that I've put in here. So we're going to go check them out. I'm going to do vim manifests Couchbase service monitor. So the service monitor is pretty crucial in terms of but basically the service monitor monitors the service, and we place this in the namespace monitoring. And what this does is it monitors for a Couchbase service, which will then, without this Couchbase service, you can't register the targets within Prometheus. There's a documentation link that I will put into the description, and you'll be able to find it on the Couchbase docs website anyway. There's a quick start tutorial with Prometheus. So exit out of that, and we'll check out the service, which basically says our port is metrics 9091. Well, the name is metrics, but the port is 9091. And we want to look for any pods with the label app and then value Couchbase, and our Couchbase cluster name. So that's how that all works. As we can, if we now look at the pods running in our namespace of monitoring, you can see we have all these good stuff, all this good stuff running. So Alert Manager, Grafana, and Prometheus, which is what we really are interested in. So if we now just follow our instructions in Prometheus and forward the Prometheus K8s pod, then go and check out localhost 9090. You can see our Prometheus server is up and running, and then check out the targets as well. And as you can see, our service monitor is showing that we have 3 endpoints here, and shows us the corresponding pods 004, 00005, and 3. So that's all working. That's all great and fine. If we go back to my terminal, stop that port forwarding, and go back to Chrome and check out how we can now forward Grafana. Just put that command in there, and then we'll go to, obviously this is no longer responding as we stopped the port forwarding, but we'll go to localhost 3000, Grafana, and the default username and password will be admin for both. You're going to change this password. I know, Chrome. We'll just change it to password and password. Save that. And then this is the part where we'll take our Kubernetes, our Grafana JSON from earlier. Can take this, copy the whole thing, go to home, import dashboard, paste the JSON in, load it in. As you can say, the name's Couchbase, and import. It will need some configuration at the beginning. So we'll go to any of these widgets and go to edit. And then as you can see, it's still got this old prepend, which is Couchbase, and then underscore. What you want to do really here, what I'm going to do here is just change that to CB, and then you can see the stats are all up and running. Obviously, I want to get this changed into JSON as soon as possible. We'll get around to doing that at some point, but that's what I will just probably go edit all these from now. We'll do a little bit of a time skip. So great, yeah, that's how you get Grafana working. So you can see we've got a dashboard that's mostly functional. But yeah, that's how easy it is to set that up. So thanks for joining me on this deep dive on Exporter. We're going to go back to the presentation. Yeah, great if you could get involved. The GitHub repo link is right at the top, and then if any issues, you can raise them at our Jira board. So thanks for watching, and have a good day.